My name is Rotem Gutman. I'm the PI for the Automated Cyber-Readiness Evaluator, the ACE program. And let me start with what the actual problem that we're looking to address is in this program. The problem is that the DoD has to staff up to a large amount of seats of cyber operators. So every one of these cyber operators has to be certified as mission ready. In order to do that, we have to have some method of doing that that's both scalable, objective, reliable, and we can assess the validity of that method. Now, what's being done right now, a lot of the time we fall back to a checklisting approach. Here's the list of knowledges, skills, and abilities that they have to display, have somebody that we trust stand over their shoulder and watch, and ask them to do task number 1, watch them do it, and then put a check mark in the box. Well, the problem with that is that what does it mean to put a check mark in the box? What if they do it like 95% of the way right? And beyond that, different evaluators can have different interpretations of what it means to put a check mark into that box in the first place. Now, me as a commander, when I get staff and I'm told that they're certified as mission ready, if I don't know what that certification means exactly, I end up having to retest them. And beyond that, the resources that I have to commit in order to do that when I'm doing one-on-one assessments aren't scalable to the size of the problem, not just for initial certification of capabilities, but with turnover, this is going to be a constant need. So how do we solve that? The ACE philosophy is basically, we always say, train as you fight. We need to evaluate as you fight. Instead of having these artificial external stimulus for our evaluations, what we really want to do is put them in their realistic environment, something that looks, feels, and acts like their normal work environment, and ask them to do their job. Give them a mission and ask them to complete it. Then what we want to do is actually understand what they did in that environment. So taking that environment in, understanding what they did in there, and then based on the actions that they chose to take in order to complete that mission, based on those actions, evaluate, okay, are they mission ready? Did they do all the things that we need them to do? Do they display the knowledge, skills, and abilities that they need? Now, the first benefit to this, obviously, is automated analysis. So if we can fully automate this process, then we don't need to devote personnel and time to actually doing these evaluations. You can assign them, go do your evaluation, and get the results back without having to put additional staff to it. But beyond that, we can actually isolate, okay, what are the specific deficiencies? Let's say somebody's assessed as not mission ready. Where are the problems? It's not just a pass-fail, but we can give them specific list of here's remediation that needs to happen. Here's where you need additional training. And based on those plans, we can also look at the recordings in the future. So we can do staff selection. We can do, as we move forward and look at their capabilities, 5 years down the line, who are your top 10% of the performers? Let's go back and look at their initial assessments. What's different about them? What are the knowledges, skills, and abilities that they possessed back then that maybe we should integrate into our training program so that our future staff can perform better? So all of that is great if you have it. So how do we build it? So this is the overview of the ACE architecture in general. Can you hear me? Okay. So basically, we need this simulated training environment. Thankfully, we have an in-house developed solution called the STEP platform. And this is, a lot of you might already be familiar with it from larger exercises like CyberFlag or CyberGuard. This is a platform that lets us push out a full infrastructure, anything from one examiner's workstation to entire bases of networks and a simulated internet and basically anything in between. In this environment, we can replicate the real-world working environment of a cyber operator. Give him something that looks, feels, and acts like where he works every day. Then, the next thing that we need to do is actually capture what they do in that environment. So we give them the mission, we sit them down in this environment. We've instrumented a suite of tools that will allow us to actually capture the activity that goes on in there. Then, using the output of that activity, we have to understand what it means. So it's not a simple problem to actually take a look at what somebody's doing on a computer screen and know what they're doing in an automated fashion. So we've instrumented a solution for that. And then the output of that is ingested by ACE Eval. This is a system that takes the output of that, takes the raw okay, here's the things I saw done, and maps them to actually what knowledges, skills, and abilities do those activities represent. Based on that, we generate a skill report, and that's the final report that gets provided either to the person being evaluated or to their commander or both, that allows you to actually see, okay, here's what the end result is. That's the useful output that we need. So I'll go into a little more detail about each one of these pieces. In order to develop this, though, the first thing we had to do is choose a role. You can't boil the ocean. There's plenty of cyber operator roles out there. We had to choose one to start. The one that we chose to start was the forensic analyst. The reason for that is purely from an engineering standpoint, a forensic analyst can be reasonably expected to be given a forensics workstation, an image, and expected to do his job. You give me all the intel you can get off of this. Is something that they can do with an extremely small footprint. Whereas someone like an incident responder, we have to build out the entire network, and just the engineering overhead is a lot higher when the research question is essentially the same. Additionally, there's a DoD standard that we could assess against. We use the standards and the knowledge, skills, and abilities that are in the JCT&CS guide, and use that as kind of informing what we're evaluating against. One of the most important things that we actually found during the course of our research is the most important criteria for doing a good evaluation is having a good standard. The good thing about evaluating in this manner is you can actually use the data that you collect to inform future standard generation and refine, okay, here's the elements of the standard that are actually problematic as you move forward. So the next thing that we needed is, as I mentioned, that mission. Okay, we've decided who we want to take. Now, what's the mission we want to give them? What do we want to put in that environment? So towards this, we actually developed two scenarios. The first one has more of a law enforcement bent. The second one has more of a DoD track for it. The first one's a missing persons case where there's suspected foul play. Basically, there's a person of interest. We went to go talk to them. Their apartment's been trashed. Somebody got there before us. We managed to recover this damaged laptop. Here's the hard drive from it. Tell us what happened to this person. The second one is a case where there's classified documents, and I say that classified for the purposes of training, not actual classified documents, that we know are in enemy hands. We know they've gotten out, the cat's out of the bag. The question is, how did they get there? Because of the nature of the classified documents, we know that they were generated by a certain defense contractor. How did they get from point A to point B? Here's we did a forensic capture of the machines in their offices. Here they are, find out how they got out. And so that's the task that's kind of given to the forensic analyst. Now, the nice things about that is there's actually multiple layers in there that are covered, distractors. There's a lot going on, just like you would expect in any office. So then, now that we have them in the environment, they have their mission, we ask them to do it. But we need to capture the data. We have to see what they're doing in the environment. Towards this, we've created a data collection capability in the Step Forward platform where we can mark anybody as under evaluation, and as long as they're under evaluation, anything they do in the system is recorded, but we actually do the recording on our end on what we're pushing out to them. So because of that, architecturally, we will not capture any of the data that they might have on their system. This lets us reach out to evaluees anywhere in the world. They could be sitting at their computer doing the evaluation. We will only capture the evaluation material, all of the evaluation material, but nothing on their system. Even cut and paste is disabled, so they couldn't accidentally, paste in passwords or sensitive information into our system. So the next step was actually go out and do this data collection, get a data set together with people that have the right capabilities. So what we needed is actually kind of a broad array of capabilities. You want to have the guy that's really good at his job, knows exactly what to do when he's given this task. The guy that's first day on the job, barely mission ready, just passes the bar for being able to be certified as mission ready. And you want the people that aren't. You want a broad array of data. So towards this, we actually did captures both with CERT staff internally. These tended to give us kind of a higher level of data. They kind of already knew what they were doing, had several years of experience, but also captures with CMU graduate students, because that gave us a much wider array. In the classroom, you have the A student and you have the, let's say, not A student. And it gave us a much broader array of data from there. Then we actually went out and partnered with a DoD partner to actually collect data from their staff, from their actual staff that are in these roles, as well as multiple additional collections, including with NCFTA personnel, industry partners, to just get a nice wide variety of capabilities. We partnered with Professor Yasser Sheikh from the CMU Robotics Institute's graphics lab. He and his graduate students have helped us design a custom computer vision system. This is that ACE vision system that takes that video feed, parses it, and determines, okay, what are they actually doing on screen? And we've managed to get really good results from that. Right now, our focus has been actually on optimizing that analysis, because its responses have been so accurate, so good, that our real focus now is just on speeding it up. We found a lot of novel solutions for optimizing that analysis, plus highly parallelizing it by using an array of graphics cards with the goal of greatly increasing the processing speed. Just to give you a kind of general idea of how we're doing this analysis, because if you tell me I can look at a computer screen and in an automated way tell you everything anybody is doing on any computer screen, great, I'm very impressed. I can't wait to hear about your Nobel Prize. But so if I was making that claim, I would understand being suspicious. I will tell you straight up, how do we do it? We cheat. We control the environment. It is a tightly controlled environment where we control what the fonts are, what the theme is, what the icons look like. And because we created the environment, we know every application that's in the environment. There's no surprises for us. So we've been able to train the vision system for that. So we're actually looking for a variety of GUI elements. Here, to give an example, one of the elements actually in the certification verifies the state of evidence. So towards that goal, they need to actually take that MD5 value that they were given and verify it. So here on the screen, our participant has done that. This is a visualization of the memory structure that's created. And if you notice, there's this nice little red dot right there, whereas this peak where it's detected that actual MD5 value being displayed on screen, which maps to that location. And that's how we know that it's been detected. Now, take that, multiply that out hundreds of times, and what you get is a description of, okay, a timestamp in the video capture, what the activity was that was detected, and some classifications on that. To give you a kind of a visual view of what that would look like, what we've done here is we have an actual video of a capture where the subtitles down here are actually the entry in what the output would look like for that timestamp. We've just synced it so that it displays on screen at the same time. And you can see that as they're going through and doing activities here, it's updating and it can tell what's going on. So now that we have that kind of description of, okay, here's what they did, how do we map that to the knowledge, skills, and abilities that they represent? We partnered with Professor Jeff Gordon at the CMU Machine Learning Department. He and his staff are actually actively helping us in creating this ACE eval system. And the idea here is that for each knowledge, skill, and ability, we're doing detection to, originally we were planning on using an entirely hybrid approach where each line in the standard, each knowledge, skill, or ability that they had to display would have its own sort of classifier, would go through the data, and for some of them, like verifying the state of evidence, it's just a binary. Either we detected that MD5 value or we didn't. For other ones where it's more of a complicated task, we'd have more complex solutions. What we've actually found is that we can get better results now with an anomaly detection system that then has a human in the loop. So what we do is we process through all of the data and have it detect anomalies of, oh, he's doing something interesting here, but I don't know what that classifies as. The system pops that up to the human evaluator, and then we train the system with, okay, that maps to this knowledge, this skill, or this ability, and then we iterate on that because now that is built in, it doesn't need to pop that up the next time, and then we get greatly decreasing interactions. But the key thing here is that also future-proofs the system against, okay, somebody does something really novel 5 years from now that nobody's ever thought of doing before, then that'll pop it up to one human in the loop and be able to now ingest that knowledge and be aware of it, and also for us to learn, oh, hey, that might be a better way of doing things that nobody's ever thought of. The final end result of this is the ACE skill report. So we have, this report gets generated. This is the gold standard end goal, to just have this come out, be sent to the commander, and basically say mission ready, not ready on each element of the standard, and then based on if they're not ready, here's a remediation plan. Here's additional training that they're going to need. As far as future work goes here, we've already designed several scenarios specifically for CPTs that are for training the different CPT sub-teams, and the sub-teams that we've isolated as relevant to this particular work, we've already designed the scenarios to be ACE compatible, so that we can take this system and just drop it down on top of existing training and have it be able to evaluate the personnel that are participating in that training. Our plans for this current year are just to increase the speed of the vision system, increase the reliability of the evaluation system, complete the work on the evaluation system end, and then also explore other use cases for this system. Because we've developed this technology, this capability, it's actually usable for a lot of other things than just doing team evaluations. We've designed it to be also modular, so if you have, if you're doing insider threat work, or if you're doing looking through drone data, or whatever the case may be, where you just need the image processing piece, it can operate independently. If you have other indicators, other sensors in your environment, you can take just the evaluation piece and feed in your data to there. And then moving forward, what we'd like to do is expand this to every cyber operator role, not just the forensic analyst, but also to evaluating at the squad level. So having an entire squad sit down, do an evaluation together, so we can certify that the entire team is mission ready.